All right, let's just continue on with some of our other examples here. Here we go. So now Abby has 14 books, but only 9 will fit on her shelf. How many different ways can she, here's a key word, arrange. That's not what I wanted to have happen at all. That keyword, arrange right here. Let's see if we can get, we really want this, there we go. Arrange. That tells me I'm doing that permutation again. She had 14 books and she only could put 9 of them on there. So if you look, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's how I need to stop at 6 and not go all the way down to 1 because I can only fit 9 books on there. This is a permutation because it said arrange. So I could use that permutation feature again. So I could do 14P9 if I wanted to, and it's going to give me that same answer in the calculator. You just have to be able to read in the context whether you should be using that permutation style or a combination. And the only difference is, does order matter or not matter? There you can see when we have the keyword like arrange or the word order, it's a permutation. Now, one that might not be as like straightforward, well, I'm going to go over it, is getting cards. Because I know some people are more like used to cards than other people. So anytime we're dealing out hands of cards, just by definition, it is going to be a combination. So if I'm dealing out cards, it's going to be a combination. I know there are lots of different types of card games, and you might play one where it does matter the first one that you're dealt. It does not for the purposes of our class and for my math lab. We're going to keep it simple. If you're dealt some cards, you could pick them up and change their order. So that's always going to be a combination. That means there's one way to work this problem. There are 52 cards in a deck. 5 of them are, you're being dealt 5, so it's 52 combination 5. Type that in my calculator. That's the answer it gave me. A couple other ones that sometimes get people, so I'm going to go over that these are combinations. This one always tends to get students about ordering. I've had students really fight over this one, but again, I can't do specific to how you might do things in real life, but in general, this is how what we think about the problem and my math lab thinks. That way we'll all be on the same page. So in this one, we're ordering food. So we want to order 4 toppings and we get to choose 10. We want to know how many different ways can we order our pizza. This word order does not mean like put in order of the toppings. We mean like place our order. It doesn't matter if I say pepperonis first or fourth, the pepperonis are going to go on the pizza. I realize some pizza places have certain orders that they choose to do, but I'm talking about you putting the order out over the phone or the internet, however you click it or say it. Doesn't matter if you say pepperoni first, second, third, or fourth, your pizza's getting pepperoni on it. That's how I know order is not important, so I used a combination. Again, I'm just typing that in my calculator. Those steps are up on Moodle, and they're also in the first video. Lotteries are the same case as the others. Order does not matter. We're going to choose our order and choose our numbers, and for our purposes, we're going to say lottery order does not matter. There are lots of different lottery games, and some of them it does, most of them it does not, so we're going to go with does not. So lotteries are going to be combinations. Now this last one is a little bit trickier. Committees are always combinations. That one's also easy to remember because it starts with a C. But a committee, everybody's the same. If I'm on the committee to oversee, like math activities for our math majors, there might be 5 of us on the committee. We all have the same responsibilities. We're all in this group together. But in this case, I've got teachers and then I also have students. So I have 2 different combinations. When we have these different groups, we have to multiply their groups together. Just like we saw in the last video with multiplying like the ice cream and the toppings. Those are 2 different groups, so I'm going to multiply them together. So I've got my teacher group right here because I had 9 teachers. Oops. So I've got that teacher group right here, and I wanted 5 of them. 9 total teachers, and I'm choosing 5. The easiest way I think to remember this is think about units. Teachers has to go with teachers. It does not want to keep giving me my little thing there. So teachers goes with teachers. So 9 and 5. Highest one always goes first. Students go with students. So our student and student have to go together. Highest one goes first. If you mess that up, your calculator is going to let you know. I'm going to multiply teachers times students. You can type this all in your calculator at one time if you want to, or you can type in just the teachers and get an answer, just the students and get an answer, and multiply them together, whichever way you're comfortable.